Regarding NPSH and an open loop system, why is it an important consideration when compared to a closed loop system?
Well, let's have a look and see what NPSH is all about. It's net positive suction head, okay? In other words, the pressure on the suction eye of the impeller. And that's the lowest pressure in a pumping system, at the actual eye of the impeller. And what we've got to do is to make sure that that pressure is above the vapor pressure of the liquid at the pumping temperature. Otherwise, we'll get vaporization, which means that the liquid turns from a liquid into a gas. And that's what we call cavitation. So that cavitation process is engendered by the phenomenon NPSH, okay? NPSH actually consists of two components. The first is NPSHA, which is a function of the system. And it represents the pressure that's on the suction eye of the impeller as a result of the system head, less the losses in the suction pipework, okay? And that will come up to a certain value, which you can calculate. And you should make that calculation for every system. There's no universal NPSHA. You have to calculate it for your individual system, okay? Then you're going to take your vapor pressure and you're going to find out from tables what the vapor pressure is for a particular liquid at a particular temperature. And you're going to take that pressure away from the pressure that you worked out for the NPSHA. So that's how you calculate NPSHA. It's the system losses less or above the vapor pressure of the liquid at the pumping temperature. NPSHR is a function of the pump, and it's given to you by the manufacturer, and it's usually part of the performance curve that's published by the manufacturer for a particular model of pump at a particular speed. And you should always look to make sure that your NPSHA is greater than your NPSHR. Otherwise, there's the potential for vaporization at the eye of the impeller. Okay? In terms of a closed loop system, there is no consideration of NPSH because there's no potential for cavitation to occur at the eye of the impeller. You're always going to be above the vapor pressure of the liquid, unless you're in some unusual phenomena. I mean, at the end of the day, if there's a lot of temperature involved, there may be an issue, but generally speaking, with clean cold water, it's not an issue in a closed loop system.